Alright, welcome to today's class, and we are going to be talking about BubbleSort algorithm. This is an interview question you face most times for tech companies like Google, Microsoft, Amazon, and the like. So the question goes this way: implement the BubbleSort algorithm and explain why it is not an efficient algorithm. So most times they'll ask you which language would you like to use to implement this algorithm. For me, I use Java. So we are going to actually explain this algorithm, but more especially, we are going to be writing the code line by line, and explaining the algorithm as we go. So I'm not going to actually write pseudocode algorithm. I'm going to, after explaining the BubbleSort algorithm here, I'm going to go to Java and then we start writing and explaining the code. So after we write the code, you'll be able to understand exactly how it works and you can write it by yourself. I want to remind you to subscribe to my channel by clicking on the subscribe button below this video so you get notified when I make new lessons, and also you kind of motivate me to continue making this lesson. And as well, if you have some questions you would like to ask me, some lessons you want me to make, leave it in the comment box below this video right now. So if you've not subscribed, click on the subscribe button below to subscribe. Alright, so now if you are given an unsorted array like the one you see here, 571384, how does the bubble sort proceed? Now, let me explain to you first where the name came from. The name came from trying to bubble a bubble inside water, trying to move it upwards all the way to the surface. So in this case, we are looking for the biggest or the maximum element in this array, and we are going to gradually shift it all the way to the end of the array. So if we have 10, it means that that is the largest element. It has to be at the extreme of the array, because if it's arranged in ascending order, the largest element is going to be at the extreme. So after the first pass, permit me to use my pen to, after the first pass, what is going to happen, after the first swap, this is what is going to happen. So what actually happens here is, on the first time the algorithm starts from here, it's going to compare 5 and 7, and then 5 and 7, it checks 7 is greater than 5 is less, no problem. Then it compares 7 and 1. In this case, we have that 1 is less than 7, and then it's going to swap. The next iteration is going to compare 7 and 3, is going to swap. The next iteration is compares, this time 7 is here now, and it goes 7 and 8, and it doesn't swap. So this is basically how the bubble sort algorithm works. Alright, so let's go ahead to implement it in Java. So let me end this presentation. Let me just end the presentation. So we go to Java. So if you are using Eclipse, just start a new file and call it BubbleSort. That is the name of the file. So there will be two loops. Remember, after we are going to explain why it is not an efficient algorithm. So the first loop is kind of the first loop is going to go from 0, int I is equal to 0, I is less than a, oh sorry, let's write a function instead of writing this inside the main method. Just write another function outside and call it BubbleSort. So public static void bubble sort, and it takes an integer array int a. Alright, so start. So we are going to loop from int I is equal to 0, I is less than a dot length, and then I plus plus, right? So at this point we are going to loop another loop from inside. This time we are looping from the position of I to the end. So we are going to be comparing the item I and checking if there is any item that is less than this item, and then we are going to swap. So let's write it for int j is equal to 0, j is less than a dot length minus 1 j plus plus. So in this case, we are iterating j and comparing pair of subsequent the current element with the subsequent element. So let's say the next thing we are going to do here is we are going to say if a j is ever less than a j plus 1. So we are going to swap. So to swap, we simply put aj in a temporary variable. Let's define a temporary variable, a temporary variable here in temp. So we can say temp is equal to aj. We can say aj is equal to aj plus 1. So we now overwrite aj. So there is a simple swap statement, a swap routine, j plus 1. This time is equal to aj. So basically, I want you to maybe look at the link in the description box. You can get access to this code, and then you can use it. So actually temp. So this is a simple swap routine, and so basically, this is how the BubbleSort works. We are done with this BubbleSort. So let's now test it using an array. So let's create a new array of ints. Ar is equal to, let's just say 3, 0, 5, 9, 2, 6 is not sorted. So let's try to now sort it. What is happening here? Alright. So I'm going to call BubbleSort on this array. So BubbleSort, and I'm going to give it AR. So after sorting it, I'm going to print it using an enhanced for loop for int item in AR. So I'm going to print this out, control space, and then I'm going to print them. I'll give a little space so that everything does not. Alright, let me use a print statement instead of a print line. Alright, so I'm going to go ahead to run it. Hopefully it's going to work. And what's temp? Item, I mean. So hopefully everything is going to work. So let's go ahead to right click. First I'm going to save it. So I'm going to right click and run as Java application. So you can see 965. So let's see. We have an error here. So equal to aj is equal to aj plus 1. Okay, so we have I start from 0. I should actually start from 1. So let's go ahead to run again. J is equal to 0 to minus 2. Okay, so let's see where this problem coming from. So if aj is less than aj plus 1, so this is where the problem is coming from. This should be greater than. So this minus 1 or minus 2 is going to yield the same result. So I'm going to run it now, and you see it sorts itself. So basically, this is where I have this glitch I solved just now. I want you to take some time, copy this code, write it yourself, and run it and see exactly how it works. This is the end of the BubbleSort algorithm. It's not efficient, and as I say, if you have an internal loop, then the running time of this algorithm is quadratic and means it's not efficient, right? Quadratic means order of n squared, right? And this means it's not efficient. So take note, if you have an internal loop, a nested loop, means it's quadratic and it's not efficient. So I'm going to stop here. I'd like to remind you to subscribe, and also like to remind you to leave a comment if this has been informative for you.